Let's now have a look at surd equations, because the first topic, the first part that we cover are exponents and surds. These surd equations that we've got, these are the ones where we've got, let's have a look at one over here, shall we? Here's an example. And we've got x minus 5 plus x minus 7 equals 0. Okay. Now, what is this? Here we've got inside here now, we've got this surd equation. What are we going to do with this? Well, remember previously we raised that to the power half, etc., etc. Well, let's just take an approach to this. Okay. The first step, step 1, is isolate the surd. In other words, get the bit that's got the surd in green there on its own. So let's take everything to the other side, okay? And then we're going to get minus square root of 5 plus x is going to be equal to 7 minus x. Multiply by the minus sign, root of 5 plus x is going to be equal to x minus 7. Okay, now we've got the surd on its own. Can you see that? It's just, let's just put this here. You see, there it is. That's our surd, all on its own. Everything else is on the right-hand side. The next step with this is going to be what? Now, yes, we are going to change the surd 5 plus x to the power of a half, okay, is equal to x minus 7. Can you see the recipe again? Here we go. What do I do now? Yep. We're going to raise it all to the power of 2, right? So basically we isolate the surd, change the surd. It's either going to be a half, a third, a quarter. Change it to an exponent, right? Then do the opposite to both sides so that we end up with just having the, you move it up here. When we square both sides, in this case, we get 5 plus x equal to, now we're going to do x minus 7 square it, is going to be x squared minus 14x plus 49 over there. Then bring it all to the right-hand side. It's minus x squared plus 14x minus 49 plus x plus 5 is equal to 0. And we then go and we work that all out, and we end up with x squared minus 15x plus 44 is equal to 0. My answer is then x minus 11, and x minus 4 gives us x equals 11 or x equals 4. There's my choices, okay? Now what do? Remember, with the exponential equations, right, where we had to raise to a power, okay, like the minus a half, we had to raise to the minus 2 to get rid of it to 1. You check solution. Check the solution. How do we check the solution? Well, we say, right, left-hand side, put the answers in. Let's have a look. It's going to be 11 minus root 5 plus 11 minus 7, and we end up, that is 11 minus root 16 minus 7, right, is equal to 11 minus 4 minus 7, which is equal to 0, equals right-hand side. Therefore, x equals 11 is a valid solution. Then we continue. Let's have a look. We put the left-hand side again. We're putting x equal to 4. This was x equals 11. This is x equals 4. So we've got 4 minus root 5 plus 4. Okay, minus 7 is equal to 4 minus root 9 minus 7. Once again, we've got this whole square root thing. You take the positive one. We've got 3 minus 7. The answer is not equal to 0. Therefore, x equals 4 is not a solution. Okay. This is all we're going to do with these. We are going to isolate the surd, then we are going to continue. We are going to solve it normally, and eventually we are going to check back our solution. Let's try this one here. Okay. Here's one. 1 plus, here we go. Example is 1 plus square root x plus 5 minus x equals 0. Okay. Right. First of all, we get everything to the right hand side. So step 1, isolate the surd. Okay, let's put it in green again. There it is. We just want that on its own, don't we? So let's go. Then we said, right, then root of x plus 5 is going to be equal to x minus 1. Now what do? I write it in exponential form. A half is equal to x minus 1. And now I square it, both sides. I apply my to the squared, and I square both sides there. That is to get rid of the square. Make it x plus 5 to the 1 is equal to x squared, okay, in this case plus 2x minus 2x plus 1. Bring it across and we get minus x squared plus 2x minus 1 plus x plus 5 equals 0. We're making it into a straightforward trinomial. Can you see most of them end up like this, right? Therefore, we end up with x squared plus minus 3x minus 4 equals to 0. Factorize that and we get x minus 4, x plus 1, leaving us finally with two solutions again, x equals 4 or x equals minus 1. We have to check. Left hand side, this is check solution. Okay, we have to check the left hand side again. So we try x equals 4 and we put in 1 plus the square root of 4 plus 5, right, minus 4. Right, let me just check. Yep, like so. Therefore, we have 1 plus root 9 minus 4, 1 plus 3 minus 4 equals 0 equals right hand side. Therefore, x equals 4 is a valid solution to the problem. I still have to check x equals minus 1. Left hand side for x equals minus 1. And we go 1 plus minus 1 plus 5 minus minus 1. Look in brackets. I'm putting them in brackets, which gives us 1 plus root 4 plus 1 is 1 plus 2 plus 1 is equal to 4, not equal to 0. Therefore, x equals minus 1 is not a solution, valid solution to this equation, right? And basically, that's how we're going to do the surd equations. Okay? I've just picked two there, but they're all going to be very, very similar at this level. That's all you have to do. So what do? We look at the equation, we say, okay, we're going to see, right, isolate the surd on its own. When we've got it on its own, if it's a cube root or whatever, you do change it to the exponential form. So it becomes the inside to the power of a half or a third or a quarter. What do we then do? The opposite, we find to multiply that to get a 1. So we multiply it by, square it if it's a 2. We cube it if it's a 3. We raise it to the 4th power if it's 1 over 4. And we do the same to the opposite side. Multiply it all out, bring it to the one side, and essentially we are going to end up with an equation that we factorize to find values for x. When we've got them, we have to check the individual solutions to see if we're correct. Here's another couple of examples on these equations. Here's one, 64 to the power of x. Example, 64 to the power of x minus 8 to the power of x plus 1 plus 16 equals 0. Okay, we're kind of here now saying, well, what are we going to do? What did we say? Step 1, prime factors. Well, let's do it. This is 2 to the power of 6 with an x on the outside, minus 2 to the power of 3 with the x plus 1, plus 2 to the power of 4 equals 0. We're not sure yet how this is going to shake down, are we? Let's now, step 2 was remove the brackets. So that's 2 to the power of 6x minus 2 to the power of 3x plus 3. Remember, that's a big error point there, isn't it? We forget sometimes to do that. And that throws us completely out of kilter. Plus 2 to the power of 4 is equal to 0. Next was we said split, didn't we? We're just following the recipe. We don't know where we're going at this stage, but let's try. Minus 2 to the power of 3x, 2 to the power of 3, plus 2 to the power of 4 equals 0. And at this point, we come to a grinding halt. Except for the fact that we say, right, now remember the little trick. Look at the ratio of those. It is 2 as to 1. What does it mean? If it's a 2 to 1 ratio, it means it's a form of, quadratic. It's a form of quadratic, isn't it? So what do? We say, right, if it's a quadratic, we must be able to solve it. Oh well, therefore, in the first bracket, I've got to have 2 brackets first of all, right, is equal to 0. Let's have a look. In the first bracket, I've got to have the square root of 2 to the power of 6. So let's say this is 2 to the 6x. What is the square root of that? Because it's got to go there. That's going to be 2 to the power of 3x. Because 2 to the power of 3x squared is 2 to the 6x. And over here, 2 to the 3x, if I multiply them, I'm going to get 2 to the 6x, aren't I? Right? Just remove that there because it was in my way. Okay, so now we can continue. Right, now we're just pretending it's an x. What do I do next? I look and I say, okay, hang on, that 2 to the 4 now, right? I can rewrite that quadratic as this. 2 to the 6x minus 8 2 to the 3x times plus going back to the 16 equals 0, correct? So I'm looking to factorize 16 and it comes out in this case to be 4 and 4. It comes to be a minus and a minus. These are the same, they don't have to be, but in this case they are. Therefore, we say 2 to the power of 3x minus 4 equals 0. I'm not going to do that one because it's the same thing. Therefore, 2 to the 3x is equal to 4. And what do? That's a simple solution, isn't it? That's 2 squared. Remember, prime factor it again. Therefore, 3x is equal to 2. X is equal to 2 over 3. Right? X is equal to 2/3. Now, that one there, okay, is it's actually a very nice one, but always remember that if you kind of running out of ideas, all right, after you've prime factored and everything with these, what do? We quickly go and we see if the ratio is 2 to 1. And in that case, we know we are onto a onto a winner. Okay. Now, let's last of all in the surds, let me now just move it up. I want to just deal with one topic finally, and that is rationalizing the denominator. Please remember that in exponents, we do not have a negative exponent in the answer. We put it to positive. We change it. So if it's 1 over 2 to the minus 3, we say our answer is 2 to the 3. If the answer is 2 to the minus 3, we say it's 1 over 2 to the 3. Remember that? What is the next step? Well, the next step is this. Is in surds. So in surds, which is where we are right at this point, we don't have never a surd in the denominator. We never have a surd in the denominator. Well, what do? We rationalize the denominator. Say we have 3 over root 3. The rule says, no, we're not allowed to have that. We multiply it by root 3 over root 3. This is called the conjugate. All right? We'll get to it, don't worry. All right? What does that mean? It means that I now multiply it. Can you see I'm multiplying it by 1, aren't I, actually? That is 3 root 3 over root 3 times root 3, which is 3 root 3. What is root 3 times root 3? Well, it's 3 to the half multiplied by 3 to the half, which is equal to, same base, we're going to add them. So it's 3 root 3 over 3 to the 1. That is 3 to the half plus a half, which is 3 to the 1, which is actually root 3. All right? I know it looks extremely weird, but trust me, it really is the same answer. Now, we're going to look at this one. Let us look at this. 3, let's make this an example. Okay. 3 over 1 minus 2 root 3. We say we're not allowed to have this. This is a big no, no, no. We may not have a root 3. Therefore, I have to rationalize the denominator, which means I multiply it through by the conjugate, which is what? Well, it's going to, this and this must be the same on top and bottom. This is going to be 1 plus 2 root 3, 1 plus 2 root 3. Yes, for those of you who spotted it, we are actually completing the square, essentially, because do you remember that it's very similar to if we had a plus b, and now we multiply it by a minus b. We know that that is the difference of 2 squares. That comes from a squared minus b squared. That's actually what we're doing here. Let's do it. On top, we end up with 3 times 1 plus 2 root 3. All over 1 minus 2 root 3 times 1 plus 2 root 3. Okie dokes? That's, come on, move up. Oops, need another page. Okay. That over there, just get it down just so I can see it. That over there is basically just, okay, is now we're going to multiply it out. What do we do to multiply out? Well, I'm just going to use a green here. We take that times that times that one times that, and that one times that one, don't we? Let's do the multiplying out. This is going to be on top 3 plus 6 root 3. And at the bottom, we've got 1 times 1 is 1. There we go, that one times that one. Then I've got 1 times 2 root 3. Then 1 times minus 2 root 3. Yep, it's going to cancel out. Not always, when you do the conjugate, it always does. Okay, and last of all, underneath I've got minus times is a minus. Remember, minus over there times a plus. This is the last terms I'm doing now. Is a minus times a plus is a minus. 2 root 3 times 2 root 3. Okay. What is this going to give us? It's going to give us 1. The plus 2 root 3 minus 2 root 3 is cancelling out, isn't it? That's going to be 3 plus 6 root 3 all over 1. What is this? This is minus 2 root 3. Root 3, 2 root 3, isn't it? Let me just write that a little neater. Minus 2 root 3, 2 root 3. These two here. Well, first of all, this is a multiplication sign. So it doesn't matter which way around I order them. So it's going to be minus 2 times 2, root 3, root 3. Well, 2 times 2 is 4, and root 3 times root 3 is 3. So it's going to be 1 minus 12. Okay? It's going to be 1 minus 12. And then, okay, what do I have? I have, on top, I have 3 plus 6 root 3 on top of 11 minus. This is the same thing as minus 3 plus 6 root 3 over 11, okay? Or it's the same thing as minus 3 minus 6 root 3 over 11, okay? All right, it's exactly the same. All I've done is put the minus here on the outside, which actually means, let me just do it like this, it means minus 1 times that whole lot, right? We don't have a minus sign down at the bottom like that. We put it to minus on the outside. Or you could change it on the top. Okay. Right, let's have a look at this. Okay. This was an old exam question. Okay. This is a multiply out thingy. Okay. This is the fifth root of root 35 plus root 3, okay, multiplied by the fifth root of root 35 minus root 3. Okay, what do we do with this lot? Okay, well, in essence, that is the same as the fifth root of root 35 plus root 3 times root 35 minus root 3 on the inside, isn't it? All right. All I've done is I've combined them because they're both fifth roots. Okay. So now I can work out, hold on, that's a multiplication thing again. Fifth root, what is root 35? Let's write it out in full. Times root 35 plus 3 root 35 minus 3 root 35. Okay. Minus root 3 times root 3. And have a look here. That's cancelling out over there. So therefore, we're ending up with the fifth root of root 35 times root 35 is going to be equal to 35. Root 3 times root 3 is going to be equal to 3, which is the fifth root of 32. Oh, how do I do that? Well, prime factor. That's the fifth root of 2 to the 5. The answer is 2. That's how that works. So, just to recap, in rationalizing the denominator, all right, you could have all sorts of weird things. You can have root 3 minus 2 root 5 on top over, okay, root 3 plus, let's say plus root 7. And we're going to multiply that then by root 3 minus root 7. Root 3 minus root 7, right? Then we multiply it out. We know the denominator, okay? We know that the denominator is going to be equal to Just let me get it over here again. We know that's going to be on top, root 3 minus 2 root 5, times root 3 minus root 2, like that. At the bottom, we're going to have root 3 times root 3. The middle terms are going to cancel out, and I'm going to have minus root 7 times root 7 at the bottom, aren't I? Okay. So at the bottom, just let's leave the top a sec. At the bottom, we're going to have root 3 times root 3 is 3, minus 7 is going to be minus 4 at the bottom. Everyone should be happy with that. On top, I'm now going to have root 3 times root 3, okay? Minus 2, this is a root 2 there, right? Yep, that's root 2. Minus 2 root 5 root 2, correct? That's plus that, right? There, okay? That's that one times that one. And then the middle term is going to be minus 2 root 5 root 3, and the other one, middle term, is going to be minus root 2 root 3. Okay, so we've now got everybody. So what do we now can multiply out. So what do we end up with on top? Root 3 times root 3 is going to be a 3. 2 root 5 root 2. The middle terms now no longer cancel out or are the same. So we end up with 2 times 3 plus 2 times root 5 times root 2. What is root 5 times root 2? Well, that is the same as root 10, isn't it? Okay, which is 2 root 10, right? Minus 2 root 15, and there is root 2 times root 3 is minus root 6. So you can end up with a completely weird thing on top, okay? Unusual, because they want you actually to cancel stuff out. But please remember, it can happen, okay? It's not a given that it can't, okay? That's the end of exponents and surd, okay? We've done 3 sessions on that one. The next we're going to go on to is onto quadratics, which is quite a long section. There's quite a lot of work to go through in that. We're going to look at the various forms of quadratic. Cheers. I hope to see you in the next session. The next one is laying the groundwork for a lot of marks. So we'll take it easy. We'll take it at a good pace and supplement it with what you're doing in class. Cheers. Have a good one. Bye.